Now YouTube, I'm slowly coming to the realization that with my push block, okay, because the size it is, okay, I would need a lot of pressure, more pressure than what I could generate with my press. Okay, and I've been having a look online. The plastic injection machines that the people have made, okay, their diameter of their pot is nowhere near this size. Okay, so that's an issue I have. It's so big, and I don't have enough pressure to push it down. Or if I do have enough pressure, then I split the tin. All right. But even still, even if I make a bigger pot to put here, I'm still going to have that issue. Is I just probably don't have enough pressure behind the push rod to actually get rid of the bubbles. If the material was more of a liquid, then possibly we might have better chance to of success. Okay, this styrene that I used here, it's quite thick to actually use, so that's why I was having problems with this one. Okay, so I probably the next one I might try with the tin, I'll probably try these ones. These ones are self-leveling. Okay, there will be bubbles that'll be in the material, but if I can push it, and we'll just see how that goes. If it pops out the side, but ideally what I want it to do is, if I push down on top, ideally I want the material to come up here. Okay. Okay, so what we'll do next is we'll use these ones. Then I think my next alternative is I will have to make a smaller push rod, and we will have to make a smaller pot. Okay. Or the other thing we can do is we'll turn up a new pot, and we'll have an injector hole at the bottom. Then we'll have another little container at the bottom. Then we'll inject straight into that, and we'll see how that goes. But yeah, so ideally smaller diameter, and that will lead to better success, I think. All right, that's it. What I'm going to do this time is I've put 4 clamps on, 4 hose clamps. What I'm going to be doing is using these lids. Since I have some like little test bits that I'd used before, I'm going to use these as the bulk material. Just put those in. Then I'll just fill up the rest with the lids. But ideally, this attempt is going to be, because the material should actually be thinner to move around. So if it's a thinner material that flows, ideally, if we should have less pressure to actually push down from above, to actually take the air bubbles out and get the fluid to try and get the air bubbles to come up. That's the idea anyway. Alright, we'll give that a go. So, hey YouTube, what I've done is, with this white one, it was actually stuck in the mould here. Well, our thin mould anyway. Anyway, so basically, to have a look at see if it was working. Okay, what I've done is I've just got the junior hacksaw, and I've just cut down there, and I've just basically peeled it away. All right, so that has worked to a degree. Okay, so what our problem is whoops, as you can see by this one here. Okay, our push rod has pushed down. Okay, it's pushed down this far, and our plastic has gone up the side as we were expecting. Okay, now what our problem is that because this is such a large diameter, okay, and my press, I would probably need maybe a 10-ton press or even a 5-ton press to actually do this right. Okay, a lot of small and plastic injection machines, they actually have sorry, I'll rephrase. On the internet, when you're looking at plastic injection machines, this is commercial machines, that goes from 5-ton right up to like 200,000 ton or something or other. Ridiculous like that. Okay, now the thing is, what we need to do is that because we have such a large diameter, okay, what we need to do is we need to refine the way we press on these tins. Okay, we are pressing at such a pressure with our bottle jack, we can actually pierce out the side of the actual tin. Okay, now my thoughts are, we've got to think about this sort of logically. Okay, we can't press on the whole tin. Okay, but what we could do is we could do a staggered fill. Okay, what we could do is, if you think about it like in like small stages, okay, we can actually press on the material at a, just say if it's that thin, we can press on the material and that would work. Alright, so now if we turn it up like that, and if we press on small amounts of material, bit by bit by bit, we should be able to get it done. That's the theory. Okay, the other thing too is that my push rod is nice, but it's too, we don't have a lot of clearance between the side and our tin. Okay, to really be a benefit, we probably should be probably a few more mil smaller. Probably we could take off another 3 mil possibly. Ideally what we want to do is we want to have the plastic shoot up the sides here. That way we know the plastic is being pressed, and the only way it can escape is straight up. Yes, I think that's the way we should go. Anyway, tomorrow I'll turn this down probably another 3 mil, and then we will see how we go. Now we wouldn't have to, doing it like that, doing it that way, doing it staggered, we wouldn't have to put as much pressure on the actual tin. That's my thoughts anyway. We'll have to see how that goes. But also another thing too is that, like, depending on the actual material itself, the plastic material that we're using. So for example, these straps, the straps I think are an easier material to work with because it flows better than if we're working with the styrene. This is a lot thicker to work with. When we melt it, it doesn't flow like water. So yes, I think that's the way we should go. We'll go for a smaller melt push. Basically, every time you fill the container, you can push it down with a knife, and that works. So the theory is that if we do a smaller push, then that should work. So I've also noticed online the people who are making these plastic injection machines, the homemade ones anyway, okay, they wouldn't have a ram this size. Okay, the ram that they would have would be probably about that size, probably about 1 inch. That way, when they push a material, they can actually push on this size. But if they tried to push on this size here, this would be almost impossible for them to do it by hand. That's what I'm assuming. Now, that's what we want to try and do, is we want to either try and get our tin to a smaller diameter, which would be good for this. But if we want a larger diameter like this, then we have to do our staggered segments. Yes, I think that's the only way we can do it. If we want a tin like this, and God knows how we would do a large diameter like this one. Like this one. This is our milk bottle press. Well, melt anyway. Okay, now to relieve air bubbles from this, we would have to put this under a ton of pressure. Yeah, I'm still undecided about that. Whether we can actually put this underneath the press and actually press it and remove the air bubbles. It should work. But because it's such a large diameter, and whether the tools that I have can actually remove the air bubbles, I'm not sure. But then again, saying that, we can actually press it quite well. So maybe that's something I need to try in one of our tins. Try some milk bottle material and see if we can press that. If we can press that, alright, then we can try a larger size. Yes, can only go up from there. So yeah.